That's why let's go to vectors, okay? And D, right now we're here. So if dA, we're given vector dA is A, okay, it's right there. And we are given dB, which is there. And we can mark as A and B correspondingly. So this is A and this is B, okay? We need to find in terms of A and B the following vectors. So first BC, okay. So BC is simply that vector, so that's why I changed the color. So from B to C. And that's going to be the opposite to the vector dA. So in our case, it's going to be just simply negative A. But I'm not going to write there. I just write that BC is simply equals, oops, not there. Let's have a look here. So BC is simply opposite to dA, which means that's going to be negative A. Okay. And obviously, because your rhombus is a parallelogram, so two opposite sides are of equal length and they're parallel, definitely. Okay. What about AC? That was 1, or I. So II is AC. Let's figure out AC. Okay. That's from here to there. So this is AC. And in this case, I think we need to complete the equation, the vector equation. Okay, so indeed, let's consider AC in this case. So let me see here. Okay, AC is 2kc, right? So if you put this point here, we can mark as K. So let it be point K. So this point K, and AC is simply double KC. And how we can figure out KC, just simply complete, just drop the triangle from where we can figure out easily. So that's going to be triangle KCB. And in this case, we need to say that, okay, we know this vector B of B over 2, yes, because K, let's mark KB and C. So KB is B over 2. Next, BC we recently found is negative A. So that's why to find KC, we just simply need to add B over 2 and negative A. So that's why KC as a vector is going to be equal B over 2 minus A. Okay, so B over 2 minus A. So that's why if we double that, we'll just get 2 times B over 2 minus A. Okay, and finally, if you expand, so expand brackets, we can write that it's going to be B minus A. That's your final result for AC. Okay, it's done. Oops, my misprint, sorry. Minus 2A, because we factorized, we expand the brackets. Okay, and finally, we need to find DC and AC. So DC is right there. What I do, I think I can erase that because we don't need it here and here. Okay, and even point, yeah. Okay, so right now we need to figure out DC, it's right there, and AC. Okay, how we can figure out the length. Okay, just write. I think we just need to write. So DC plus AC. Let's express. So DC is simply, let me see, DC, did we find it? No, before never, okay. So let's build up triangle DCK. So for example, that one, this is DC, and this is, let's say, dk, and this is just goes up. Okay, and just mark them. So this is D, this is the point K here, so K, and the top one is C. So that's why DC from there is going to be dk, which is half of B again. So this is half of B. And KC we recently found is B over 2 minus A. So this is the whole expression, B over 2 minus A. Okay. So that's why we just add them using head to tail rule, or just basically triangle addition. And that's how we can figure out DC. So DC is going to be equal to B over 2 plus B over 2 and minus A. So we just add dk and kc. So finally we'll get B minus A. So that's what it stays for DC. What about AC? So AC, we can find from the small one, probably from the small triangle. Let me see. Oh, okay. We found KC. Yes, so that's why AC is twice. Yeah, we found it. Sorry. We found it in the previous step. Okay, and that's why AC is right there. This is AC. So AC is B minus 2A. Okay, now we just plug, we add those values together. So DC and AC, if we add, we'll get 2B, right? B and B, and A and negative A and negative 2A, negative 3A. So we'll get 2B minus 3A. Okay. So that's final result for DC. Okay. So it's done, and let's go to the next one. In question E. So M is the midpoint, so it's right there. It's right there. So we need to find DM. Let's find vector DM, okay? From there to there, okay? How to find NDF? But first let's figure out DM. So how to find DM right there. Okay. In terms of A and B. So to find DM, we simply need to consider definitely triangles again. So we know that BM, so actually because all 3 points, B, M, F, and A, they're all lie on the straight line or straight segment AF. And on top of that, because BF will have the equal length of DC, it forms the parallelogram. So we definitely know that BF is the same as AB. Okay, so those two sides are the same. So that's why MB is simply half our BM as the vector. BM we can fix so that BM is the half of vector BF or AB. Okay, it's half of AB. Next, let's see before. No, we didn't find that before, so that's why now we need to find vector AB. So we know, one more time, we know vector dA, which is A, and we know vector B, which is there, okay? So this vector B, this vector A, okay? And we can add dB. Oh, we can complete, okay. So let's complete the triangle equation. So AB is there, AB. If we add with vector A, according to triangle rule, we'll get vector B, okay? So that's why from here, we can see that vector AB is simply the difference B minus A. Okay. So we've done BM, and that's why BM is 1 over 2. So that's why right now we know BM. I mark with that blue one, okay? We know BM, and BM is simply half of AB. So AB is B minus A, so that's why we just plug B minus A and 1 over 2. And according to triangle again, DB, which is B, plus BM will form our vector DM. So that's why vector DM right now is going to be equal to vector DB and plus vector bm that we recently found. So if we plug db as b and we plug bm as 1 over 2 b minus 1 over 2a, I just expand that, okay, so right there, I'll get 3 over 2b and minus 1 over 2a, okay? So that's why finally we've got dm. So dm is 3 over 2b minus 1 over 2a. So that's why that's finally that we have for dm. So what about df right now? So df is simply that vector from point D to the point F. So this is the vector that we're looking for, okay? And obviously df is just simply vector b plus vector bf, which is the same as ab. So that's why we can write plus bf, but bf the same as AB, and AB we already found here, okay? That's AB. So that's why finally we'll get 2B minus A. That was stay for DF. Okay, we just plug the values, and that's why it's 2B minus A. So done with E part, and finally, let's go to the part F. So we need to find the lengths of vector dm and df, okay? Even if we know that 3 over 2b minus 1 over 2a, we have no idea about how to work out the lengths, right? So the lengths can be worked out using triangle rules, yes? Or, let me see, if we know vector b, we have no idea. So that's why we need to hire up trigonometry. We don't have any coordinates for the vectors, so that's why unfortunately we cannot use the vector approach. So use trigs. For F, we're gonna use trigonometry, obviously. dm, so dm. Why trigonometry? Because this is the side of triangle DMB. So trigs from triangle DMB. So triangle DMB. Okay, so we know this side is 4, this side BM is half of 5, so that's why it's 2.5 centimeters, okay? And do we know the angle? So angle DBM. So angle DBM, because right now I'm going to use the cos rule. So cos rule for the triangle. So DBM. So we know this angle, obviously. Let's go back to the angles. It's right there. Okay, it's here. So we found that angle CDA. Let me see, DCB. Yeah, okay. I'll just explain it in a moment. Okay, we can consider DBM as the sum of the angle. This is the angle. So DBM we can consider as the angle DBC, okay, and plus the top angle CBF, okay. DBC, as you remember from previous case, that was angle theta, right? If I'm not mistaken, so that was angle DBC. Oh, it was alpha actually, and let's fix the value for alpha, 66.42. So that's why not theta, but angle alpha, 66.42 degrees, okay? So what about angle CBF? In this case, CBF is the same as the angle C, which was theta. And we know also that, let's go back and find angle theta that we recently found. So theta is that one, right? But we twice right now. So theta is the half, but we're going to twice that. So twice theta is 47.16. Okay, angle DCB. So 47.16. Okay, so that's 47.16 degrees. Okay, and we need to find the total angle. Let's add them up. So let's see how much we'll get. So 66.42 and plus 47.16. So we'll get, in total we'll get 113 and 58 degrees. Okay, so now we know the angle. What we're going to use, as I promised, we're going to use trigonometry, and that means we're going to use cos. So unfortunately I don't have the space, but I'll write finally. So that's we're looking for dm length. So dm length is gonna be equal to square. We're gonna add 4 squared plus 2.5 squared, and we take away double product of 4 and 2.5 and times cos of that angle, cos of 113 and 58. Okay, so that's why finally if we calculate, we're taking the square root. Let's do it quick. So 16 plus 2.5 squared, and we take away 2, so we're taking away 8 times 2.5 and times cos of the angle 113 and 58. Okay, so that's the final solution. That's going to be 5.5 centimeters. That was stage for dm. Okay, what about df? So df right now, I'm going to use the yellow color for df, and there is going to be this one. So df is going to be, again we're going to use the same cos rule, so that's why df is simply, so absolutely, we're going to use 4 squared. Now in this case bf is the whole side, so that's why we're going to add 5 squared, and we take away 2 times 4 times 5 times cos of that angle 113.58. Okay, and that's final solution for df. So we take in square root and just quick recalculate. Square root of 16 plus 25, take away 2 times 5, 10, 40, okay, 40 of cos 113 and 0.58. So finally we'll get 7.55 or 7. So df finally absolutely is going to be around 7.55 centimeters. Okay, so we've got everything, and yeah, that was pretty long, but that's pretty hard questions because you need to be oriented and and several topics there. So we've covered not only vectors but also how to find lenses, how to find how to work with vectors in terms of addition, and how to actually use trigonometry. Okay, first trigonometry. Hope you like that. I decided intentionally to work on this problem because it seems to me it's pretty hard for majority of students for GCSE. Okay, subscribe if you're new here. Don't forget to smash the bell button to be notified about latest updates, and see you soon.